Hello. Today's lesson is about the different types of relationships. Relationships between values. The relationships can be linear or nonlinear, and if they are linear, they can be either proportional or non-proportional. We are going to talk about how to recognize when they are linear or nonlinear and when they are proportional or non-proportional. Earlier in the year, we worked with proportional and non-proportional. This is not new, but it is a review. Okay. So there's all sorts of relationships, but basically they come down to two different kinds. Linear and non-linear. Now, nonlinear relationships, nonlinear equations, nonlinear functions, they're great, they're just not linear. Linear comes in two different kinds. We either are proportional or non-proportional. There is no such thing as a proportional nonlinear relationship. That doesn't exist. To be proportional, it has to, by definition, be a linear equation, a linear relationship, a linear function. All right. If you're going to look at graphs, if it is nonlinear, then it's not a straight line, hence the term linear. If it is linear, then it is a straight line. Then, looking at linear, if it's proportional, it goes through the origin, which is 0, 0. If it's non-proportional, it does not go through the origin, 0, 0. Okay, here's this first graph. This is a curvy line, so it is non-linear. Why is it non-linear? It's curvy. Or not straight. Not straight is fine also. These two are straight lines, so both of them are linear. Now, this one does not go through 0, 0. Therefore, this is non-proportional. And why not? Not through 0, 0. This one is linear because it's a straight line. Does it go through 0, 0? It does. That is why this is proportional. Why? Because it is straight and it goes through 0, 0, the origin. So that's that one. Next one. Okay, if you have an equation, then if it is nonlinear, it will use operations other than multiplication and division and or addition and subtraction. And its exponent on the variable is not 1. You know that x is equal to x to the first power. So if you don't see an exponent, the exponent is 1. If it is linear, then it uses only multiplication and division and or addition and subtraction. If it is proportional, it uses only multiplication and division. If it is non-proportional, then it uses operations other than multiplication or division. And you know, multiplication and division are the same thing, and addition and subtraction are the same thing. I don't have to say that. You know it well enough. Okay, here's this first one. Well, look, there's an exponent. It's 2. That's not 1. This is non-linear. And you say that the exponent is 2. That's why it's non-linear. Here's this next one. It uses multiplication. It uses addition, so therefore, since it does not only use multiplication, this one is linear, but it's linear because the x is only x to the first power. It is linear, and it is non-proportional. And why is it non-proportional? Because it uses subtraction. Right there. Subtraction. Here's the third one. Y equals 3x. Well, it's linear because it's x to the first. Is there any addition or subtraction? No. So therefore, this is proportional. Why is it proportional? Only uses multiplication. So that's that one. What if you have a table? If it is nonlinear, it does not have a constant slope. If it is linear, it will have a constant slope. If it's proportional, it has a constant ratio of proportionality. If it's non-proportional, then it does not have a constant ratio of proportionality. So let's test them. We're going to start on this one over here. Well, constant of proportionality is y over x. So negative 8 over negative 4 is equal to 2. 10 over 6 simplifies to 5 to 3. Are those two equal to each other? No. So therefore, this is not proportional. We'll come back to it in a moment. Let's see this one. 15 over 8 can't simplify. 12 over 6 turns into 2. Is 15 over 8 equal to 2? No. This is also non-proportional. Let's try this one. 12 over 8 simplifies to 3 over 2. 9 over 6 simplifies to 3 over 2. Negative 6 over negative 4 simplifies to 3 over 2. This is proportional. And why is it proportional? Because it has a constant ratio of proportionality. And the proof of that is right up here, where they all simplify to 3 over 2. Okay, this one's proportional. So, are both of these linear, or is one of them nonlinear? Well, if it's linear, it has a constant slope. So let's find some slopes. Okay, to do some slopes, remember, we have to subtract. So y minus y. 15 minus 12 over 8 minus 6. Notice I went this way and the same direction. Don't mix it up. 15 minus 12 is 3. 8 minus 6 is 2. That's 3 halves. Let's do another one. That's just one of them. We have to test all of them. So we'll do negative 3 minus 12 over negative 4 minus 6. Notice I went this way and this way, y on top of x. That's negative 15 over negative 10, which simplifies to 3 over 2. Is 3 over 2 equal to 3 over 2? Yes, it is. That means that this is linear. Why is it linear? It has a constant slope. By the way, I compared this one and this one, and then I compared this one and this one. I did not do the first to the third. You don't have to. If it works first to second and second to third, then it's going to work first to third also. It's fine. All right, so we know that this third one is non-proportional. Let's see if it's linear. Let's find some slopes. 12 minus 10 over 8 minus 6 is 2 over 2 is 1. Okay, now let's do this one. 10 minus negative 8 over 6 minus negative 4 is 18 over 10. Is 18 over 10 equal to 1? No. That means this does not have a constant slope. This is non-linear. And why is it nonlinear? No constant slope. So, that's the deal with tables, okay? Next thing, situations. Okay. If it is nonlinear, then it does not have a constant rate of change. If it is linear, it has a constant rate of change. It's very similar to slope. Slope is a rate of change, same thing. If it's proportional, it has a constant rate of change and it also starts at 0. If it's non-proportional, then it does not start at 0. Okay, well, let's look at them. The The club started with $20. Is that 0? No. This means it's non-proportional. It might not be linear. We'll leave it alone for right now. This club started with no money. Hey, look, it might be proportional, but also might not be linear, so we'll leave it alone right now. The club started with no money. Hey, it starts at 0. It could be that it is proportional unless it's nonlinear. So let's take a look at these two and see if they are linear or not. We need to look at their rate of change. If it's the consistent, then it's linear. If it's not consistent, it's nonlinear. Okay. So, started with no money. First week, it had $50. How much did it earn in the first week? $50. At the end of the second week, it had $80. It went from 50 to 80. What's 80 minus 50? 30. So in the second week, it made $30. Are they the same number? No. Does that mean it has a constant rate of change? No, it means it does not have a constant rate of change. Therefore, this is non-linear. No consistent rate of change. 50 is not equal to 30. Here's where we get 50. Here's where we get 30. That shows the work. All right, so this is non-proportional, or it might be proportional. If it's proportional, then it will have a constant rate of change starting at 0. Okay, started with no money, first week, $30. What's 30 minus 0? That's 30. Second week, what's 60 minus 30? 60 minus 30 is 30. Is 30 equal to 30? Yes. And it starts at 0, so therefore this is proportional. Why is it proportional? Starts at 0 and consistent rate of change. Okay. Now, we know that this one doesn't start at 0. Therefore, it is non-proportional. But is it linear? Well, to be linear, it has to have a consistent rate of change. They started with 20. At the end of the first week, they had 50. What's 50 minus 20? That's $30 in the first week. At the end of the second week, they had $80. What's 80 minus 50? It's also 30. Are those two equal? Yes. Therefore, this is linear, but non-proportional. We know it does not start at 0. But it does have a consistent rate of change. Don't worry, on your worksheet you're going to have more space than this. All right, so that has to do with tables. So next, that had to do with situations. So we have graphs, equations, tables, situations. Let's do an example. All right. These are graphs. So, first of all, which ones are straight? This is straight, so it's linear. This is straight, so it's linear. This is curved, so it's nonlinear. This one will give a reason. There's no work that you need to show. It's obvious. The reason is not straight. Oh, I tipped the wrong button. There I am. Or curvy. And that's fine. Now, here are these two linear ones. The one that goes through 0, 0 is proportional. So it's proportional. There's no work needed to show. It is straight. And it goes through 0, 0. That's your reasoning. This one does not go through 0, 0. Therefore, it's non-proportional. No work needed to show. It is straight. And it goes through 0, 0. That's your reasoning. That's how you take care of graphs. Next one. Equations, huh? Okay, so let's go back and look at equations. For equations, if it uses only multiplying and dividing and addition and subtraction, then it's linear. If it uses only multiplication and division without addition and subtraction, it's proportional. If it uses other than multiplication and division, then it is going to be non-proportional. Okay, so this one, it uses division, but do you see that x is in the denominator? That means that this is equal to x to the negative first power. Is negative 1 equal to positive 1? No. I mean, this is nonlinear. There's no work to show. Your reason is it is x is in the denominator. Hit the wrong button again. There we go. All right. This one, x is in the numerator, so x is equal to x to the first power. So it is linear. It's fine that way. It's using only division. It's dividing by 3. Is it using any addition? No. Therefore, it is proportional. There's no work to show, but we can say that x it only uses dividing. And that's enough to say that it is proportional and linear. This one, it's using dividing. X is in the numerator, so it's x to the first power. That's fine. And so it is linear. Is it proportional or non-proportional? Well, see the addition? Addition means that it is non-proportional. No work need to show. You just have to say that it uses addition and multiplication only. And you have to say only because if it used addition, multiplication, and exponents, then it would not even be linear. Okay. Tables. All right. Well, the tables means we're going to have to do some work. All right. First thing, let's see if it is proportional. Proportional is the easiest thing to check on tables. All you have to do is put y over x and see if they're equal. So 5 over 3 is equal to 5 over 3. 15 over 9 is 5 over 3. This is looking good so far. 35 over 21, divide them both by 7, we get 5 over 3. Hey, it's proportional and linear. Reason, it has a constant. Oh, tapped the wrong button again. There we go. Let me zoom in a little bit. Constant ratio of proportion. Good. Okay. Let's look at the next one. 8 over 3 is equal to 8 over 3. Doesn't simplify. 20 over 9 also doesn't simplify. 8 over 3 is not equal to 20 over 9. This is non-proportional. Let's see if it's linear. So we'll do some slopes. Okay, 28, 9, 3. 20 minus 8, 9 minus 3. That's 12 over 6 is 2. The slope for those two is 2. 45, 20, 21, 9. 45 minus 20, 21 minus 9 is 25 over 12. Doesn't simplify. Is 2 equal to that? No, it does not have a constant slope. It is nonlinear, and your reason is no constant slope. And the work here demonstrates that. All right. We don't have to check whether it's proportional or not. Since it's not linear, it can't be proportional or non-proportional. All right, let's see this one. Well, we don't know that it's non-proportional. Let's say 8 over 3. Can't simplify. 18 over 9 is 2. 2 is not equal to 8 over 3. It's non-proportional. So now we just have to figure out if it's linear or nonlinear. You probably realize that it's going to be linear because I wouldn't put in another one. But 18, 8, 9, 3. So 18 minus 8, 9 minus 3 is 10 over 6. It's 5/3. 38, 18, 21, 9. 38 minus 18, 10, I'm forgetting, 21 over 9. 21 minus 9. 38 minus 18 is 20. 21 minus 9 is 12. Divide them both by 4, we get 5 over 3. Hey, it is linear, non-proportional. And we know it's non-proportional. So, reason, it has a constant slope. And this work shows that it has a constant slope. And that's how you deal with tables. Last one. All right, situations, right? So, back to situations up here. If it has to start at 0 to be proportional, so let's take a look. At the beginning it was 0, starts at 0. At the beginning was 4, doesn't start at 0. At the beginning it was 0, starts at 0. Okay, so these two might be proportional. We don't know about this one. Let's see if this one is linear. If it's linear, it has a constant rate of change. Okay, 0 to 3, beginning is day 0, 12. So that would be 12 minus 0 over 3 minus 0 equals 12 over 3, which is 4. Let's see, 15 minus 12 over 5 minus 3 is 3 over 2, which is not 4. Therefore, this must be non-linear. And how do we know? No constant slope. Okay. We know this is non-proportional because it doesn't start at 0. Let's see if it has a constant slope. Okay. Day 3, day 0, 4, day 3 is 12, 0 day is 4. So we'll do 12 minus 4 over 3 minus 0 equals 8 over 3. 14 to 12, 5 to 3. 14 minus 12, 5 to 3. 5 minus 3, 2 over 2, which is 1. Is 8/3 equal to 1? No. Therefore, this is also non-linear. Reason, no constant slope. Okay, last one. We know it's not proportional. Let's see if it is linear. All right, we know it could be proportional, so let's see if it's linear. So 12 to 0, 3 to the beginning. Okay, 12 minus 0, 3 minus 0, 12 over 3 is 4. Okay, let's see this one. 5 to 3, 20 to 12. 5, oh, I made a mistake. Have to put a y on top. 20 minus 12, 5 minus 3 is 8 over 2 is 4. That means it is linear because it has a constant rate of change, and it is proportional because at the beginning it was 0. So reason, starts at 0, and it has a constant slope. test one more thing real quickly. 12 divided by 3 is 4, 20 divided by 5 is 4. It's another way to show it, but I like to be consistent, so I actually found the slope instead of just finding the constant of proportionality. All right, try the worksheet. Write to me if you have any questions.